Welcome Algebra 2A folks. This is going to be a video for a lesson, and the learning target for this lesson says I can solve systems of equations with elimination even when they are not set up for elimination. When I say they're not set up for elimination, I mean they are not ready for elimination. So let's review real quick here. The elimination method is when we add equations. And when we add those equations, one of the variables cancels, or you might say is eliminated. Hence the phrase elimination. So one of the variables cancels or is eliminated. So quick example, I'm just going to make up a system. This isn't going to have a nice solution, so I'm not going to go through and solve the whole thing, but maybe one of our equations is 3x plus y equals 18, and we have another equation that's like negative 3x, plus 5y equals negative 11. And so if we were to add these together, the positive 3x and the negative 3x added together would be 0x, which is 0, but we would have 6y would equal 7. Now that's not going to have a nice solution, but I'm just showing you an example, reminding you of what it looks like when one of the variables cancels or is eliminated. So the reason that happens, or how we can tell, I should say, continuing with the notes here, we can tell that a system is set up for elimination if one of the variables has opposite coefficients. So that example we just had right there, we had the positive 3x and the negative 3x. Those are opposite coefficients there. If I can make my eye a little bit nicer. So right here, I'll write it out. There you go. 3 and negative 3 are opposite coefficients. When you add those together, it's 0. 3 plus negative 3 is 0. 3x plus negative 3x is 0x, which is 0. So down at the bottom of the page right now, at least on the screen, says, but what if the system is not set up? Or what if it's not ready for elimination? What would we do then? I'm going to scroll down here. All right, so our first problem on this note sheet says, follow the instructions to set up the system for elimination, then solve and check. So we got the equations there, and we are instructed for the first equation to multiply by 5. Now, you might remember this, we're going to multiply the entire equation. So a lot of people like to put the entire equation into one set of parentheses. We're going to multiply by 5, so put that outside the parentheses. But we're going to distribute this. We're going to do 5 times 8x, that's going to be 40x. We're going to do 5 times 3y, that's going to be positive 15y. And then I might need the calculator for this one, 5 times negative 94. Here we go, 5 times a 94, that's negative. That gives me negative 470. So that's based on the first equation, and I was given those instructions to multiply by 5. For the second equation, our instructions are to multiply by a negative 8. So again, maybe put the entire equation in one set of parentheses, put that negative 8 outside, and then we're going to distribute. Negative 8 times 5x is going to be negative 40x. Negative 8 times positive 4y is a minus 32y, or negative 32y. And then, yeah, I might want the old calculator again there for negative 8 times negative 63. Let's see here, and 8, 8 that's negative, there we go, times, let's start over again. And 8 that's negative times, there we go, 63 that's also negative is equal to 504. So now you might notice that we have an opposite coefficient, positive 40x and negative 40x. If I add these new equations together, we will get some elimination. We'll get some cancellation here. So if I add these equations, what do we get as a result? So let's see, 15y and negative 32y is negative 17y, and then negative 470 and 504, that is a 34. So let's see here. Remember, this is a huge thing with a system of equations, is that we went from 2 equations with 2 variables. We've created one equation that only has one variable. So I can pretty quickly solve this for y, divide by negative 17, cancel that, divide by negative 17, and we get y equals negative 2. Whoops, y equals negative 2. Let's write that a little more nicely. I'm going to finish solving this, though. So now I need to solve for my x value, and this is where I get to pick. I can choose the first equation, I can choose the second equation. To me, I don't know. I guess that second equation looks a little nicer. We got some smaller numbers there. So I'm going to take that y value of negative 2 and I'm going to put it there. So we have 5x plus 4 times a negative 2 equals negative 63. By this point, this should be, nothing new for us, I would hope. So I'm going to go kind of quickly, but, certainly pause the video at any point if you need to. 5x plus a negative 8 will equal a negative 63. I can add the 8 on both sides. Cancel the negative 8. This will be 5x equals negative 55. And then x equals, whoops, I got to divide by 5. There we go. Divide by 5, and x will equal negative 11. All right, so I believe I've solved the system. I got an x value, I got a y value. Now I'm going to check, and since I used the, we'll go blue here. Since I used the second equation to get the second variable, I'll check the first equation. So that would be, is 8 times my x value of negative 11 plus 3 times my y value of negative 2. Is that equal to negative 94? So I've said it before, I'll say it again. You could do all of this on the calculator if you want the left side. I'll break it down here. That's a negative 88, whoops, plus a negative 6, and I do believe that equals negative 94. So negative 94 equals negative 94. That is true, which is good. So yeah, I'll just write my answer clearly here. And I'll do the coordinates, the ordered pair. So x is negative 11, comma y is negative 2. And we are done with that one. Okay. So scroll down here a little bit. But if you notice what we did there, at the beginning, we had 8x and 5x. Those were not opposite coefficients. We had positive 3y and positive 4y. Those were not coefficients. But I manipulated both of those equations to create opposite coefficients. And I did that by multiplying. So to set up a system for elimination, we can multiply. Let me switch to a different color here. We can multiply each equation by the coefficient of the other equation. So picking one of the variables. If you want to set up x to be eliminated, look at the coefficients for x. If you wanted to set up y to be eliminated, look at the coefficients for y. One little thing we got to be careful of here is we just want to make sure that the coefficients end up as opposites. So meaning one positive, one negative. Positive / negative. Okay. But yeah, so let's try out another example here on the next page. So it says set up each equation to be solved by elimination, then solve and check. So again, if you notice right away, if it's ready for elimination, go ahead and just add the equations, but 7x and 10x added together, I'll just write this out. I'm going to erase this, but if we add this, I'd have 17x. Okay, x is still there. And 5y and 6y, that's 11y. And then whatever this comes out to, that's 300 something. But I still have x and I still have y. Neither one was eliminated because it wasn't set up. It wasn't ready for elimination. But we just saw in the previous example, and we just talked about how we can set up the system to be eliminated, for elimination, excuse me. So what I'm going to do here is I'm going to set x up for elimination. We could set either one up. And I'm just going to make a note of that real quick. So there you go, up the top there. We can choose to set up x or y to be eliminated. In this example, I'm just going to choose x. It doesn't seem that one is necessarily easier than the other. And I don't know, x being the first variable in each equation, maybe it's just easier there. So we said, what did we say here? Let me scroll back up quick. We can multiply each equation by the coefficient of the other equation. So I can say, all right, let me take that first equation. If I'm setting this up for x to be eliminated, I'm going to multiply by the coefficient of x from the other equation. So the second equation, the coefficient is 10. So I'm going to multiply that. So my new first equation, 10 times 7x is 70x. 10 times 5y is 50y, positive 50y. And then that will equal 10 times 138 is 1,380. Remember that we want one coefficient to be positive, one to be negative. They need to be opposites. So when I do my multiplication for the second equation, right now it's a positive 10. If I multiplied by 7, I'd get 70x. I go, ooh, no, I want one of them to be positive 70, the other to be negative. I go, ooh, that's easy. Just make that a negative 7. Negative 7 times 10x will be negative 70x. There we go. there's my opposite coefficients, but I got to keep going here. Negative 7 times 6y, that's going to be a minus or a negative 42y, and then that will equal negative 7 times 188. Got to check the calculator on that one. Negative 7 times 188, negative 1316. All right, but now I'm set up. Now I'm ready for elimination. So I encourage you, pause the video at this point, see if you can finish solving this, and otherwise I'm going to go quick. All right, so now that I got those opposite coefficients, x is going to cancel here. Again, remember, I could have set y up to be eliminated. I chose to do x, but this will be 50 plus negative 42, that's 8y. Here, I think this is going to be 64. I'm going to double check on the calculator though. 1,380 plus a negative, whoops, not that one, negative. 1,316, that's negative. Okay, yeah, 64. All right, so divide by 8. That gives us y equals 8. Remember, that's a coincidence, excuse me, that it's the same coefficient that I had for y up above. Let's see, I'm going to go back to the originals, go back to the original equations in case I had a mistake when I changed those equations. I think I'll take the first equation. And so we have 7 times x plus 5 times, I think y is 8. And that's supposed to equal 138. That'd be 7x plus 40. 5 times 8. I can subtract that 40. That'll leave me with 7x equals 98. And let me scoot down here a little bit. But I believe if I divide by 7, what is that going to be? I think that's 14. We'll double check on the calculator. 98 divided by 7. 98 divided by 7 is 14. All right. So x equals 14. All right. So I believe I've solved the system. I think the y value is 8, x value is 14. So let's check the other equation. We used the first equation here, so I'm going to check the second equation. All right, so 10 times my x value is 14, I think, plus 6 times, I believe the y value is 8, and that's supposed to equal 188. Is that true? Well, this is 140. This is 48. Yeah, that's looking good. 140 plus 48 equals 188. Put a question mark there, but yeah, 188 equals 188. That is true. So I like this. I like my work. I like my answers. So my final answer, just to make it clear for everybody, in coordinate form or ordered pair, 14 for x, 8 for y. Do I have space here? Yeah, so I'm just going to real quick, if you wanted to, again, you could set this up for y to be eliminated. I just chose x. But yeah, let me pause here real quick. So if you wanted to set y up for elimination, it's your choice. Maybe it just seems easier for you. But then I'm going to be looking at the coefficients of y. So I'll take the 6 as the coefficient from the second equation. I'll multiply that first equation by 6. So this will become 42x plus 30y equals, oh boy, what's 6 times 138? Calculator, help me out, please. 6 times 138, 828. But then I would also have to modify or change or manipulate the second equation. Multiply by 5. Ooh, but remember, we want opposites. So right now, this is heading for 50x. This would be plus 30y. I go, no, I want a minus 30y. So all I got to do is make that a negative 5. That'll make that negative 50x. Negative 5 times 6y is negative 30y. And then negative 5 times 188, whatever that comes out to. Negative 5 times 188, negative 940. So I'm not going to go through and solve it again because it's the same system. I should get the same results. I should get, in this case, I'll be solving for x first. But I should get that x equals 14, and then putting that back into either the first or second original equation, I should still come up with y equals 8. So again, it's your choice. Do you want to set x up to be eliminated? Do you want to set y up to be eliminated? I made the choice to set up x for elimination. Okay. All right, we got one more on this this note sheet. So the same thing right now. If I think about this, If I try to solve this with elimination, if I add these equations, 6x plus 4x is 10x. I'm going to erase what I'm writing down, so don't copy this down right now. Positive 5y plus negative 3y is a positive 2y, and then this would equal, I think that's a negative 14, but it doesn't matter because I still have x and I still have y. And again, if you're thinking ahead, you might go, yeah, why would we add? They're not opposite coefficients. It's not set up for elimination. So I'm going to manipulate this. I'm going to get it set up for elimination. This one, I'm going to choose to set up y for elimination. And again, it's not wrong to set up x for elimination. The reason I'm choosing y for elimination is I already have opposite signs on the coefficients of y. So I don't have to worry about, like last time, like, oh, wait, but make one of them negative when you multiply. I go, no, I already got a positive coefficient of y in the first and a negative coefficient of y in the second equation. So I'm just going to take a positive 3 from the second equation and multiply this. So 3 times 6x is 18x. 3 times a 5y, positive 5y is positive 15y. And then 3 times negative 35 is, I think that's negative 105, but let's double check. 3 times a negative 35. Negative, oops, here we go, negative 105, there we go. For the second equation, switch up my color here. Again, I'm just going to take the 5. I'm already going to get a negative 15y. 5 times 4x will be 20x. 5 times a minus 3y is a negative 15y. There's my opposite coefficients there. 5 times 21 is 105. Ooh, here's something interesting. We're going to get 0. But yeah, but again, notice that it wouldn't be wrong to set x up to be eliminated. It just, for me, was easier since you already had positive y and negative y, positive coefficient, negative coefficient. I didn't have to worry about multiplying one equation by a positive and the other by a negative. But yeah, y is going to be eliminated here. We're going to get 38x when we add those, and then this is going to be 0. Technically, I still need to divide by 38 on both sides. Don't forget, I feel like a lot of students forget, at least to show me that they're doing 0 divided by 38. But this means x is going to be 0. And that's okay. That happens sometimes. Sometimes your variable has a value of 0. Now I'm going to go back to the original equations. I'm going to use, let's see here, the original first equation doesn't have any negative coefficients. So the first equation, if I do 6 times 0 for x plus 5y, that's equal, whoops, getting a little crazy here. I'm getting a little sloppy with my drawing. That is equal to negative 35. So this is nice because 6 times 0 is 0. And I mean, if you want to, you can say, let's subtract 0. But if you remember, like back here, it was 0y, and I didn't have to bother writing that down. This is just 5y. If you really want to subtract 0, that's the process. But you could just say that's just 5y equals negative 35. You can just cut out the 0 plus, you can just say 5y. Divide by 5, and we're going to get y is negative 7. So let's check though to be sure. Let's get that other equation here. Let's see. We'll go with that color. So check the second equation. Whatever equation you didn't use to get the other variable, the second variable. 4 times that x value I think is 0 minus 3 times the y value I think is negative 7. And is that equal to positive 21? Well, let's see. 4 times 0 is 0. Might want to chop slash that. If you treat it as a negative 3 times a negative 7, that would be plus 21. Yeah, this is looking good. 0 plus 21, that's 21. That is true. So my final answer to this system, the solution to this system, x is 0, y is negative 7. The only other thing I'm going to do here is I'm going to just show you if you wanted to set x up for elimination. I'll try to do that quickly. So if you wanted to set x up for elimination, again, it's not wrong to do that. I did it for y, but you could choose x instead. So I'm going to take the coefficient from the other equation. So 6x, I'm going to multiply that by 4 from the other equation. That's going to give me 24x when I do that, plus 20y and that's going to equal, oops, 20y, there we go. That's going to equal, that is negative 140, I'm pretty sure. But then here, I'm going to multiply by a 6 from the first equation, taking that coefficient from the first equation. But remember, ooh, that's going to give me a positive 24x again. No, I want them to be opposite, one positive, one negative. Okay, so let's make it a negative 6. Negative 24x, negative 6 times 4x. Negative 6 times negative 3y is positive 18y. And then that will equal negative 6 times 21, which I believe is negative 126. But yeah, so again, I'm not going to finish solving that because I already solved it. And I'm confident that 0, negative 7 works because I checked that. But now you're setting x up to be eliminated. And if that's what you want to do right away, that's fine. It's okay to do that. One other thing I don't think I mentioned in this video is we could switch this and say, well, what if you wanted to make the 4 here negative and make the 6 positive? And that's just going to change. That's going to be a negative 4x, negative 20y, positive 140, positive 24x, negative 18y, positive 126, but you still get that cancellation there. So this is a little tough to teach sometimes because there are so many options you have. You can set x up to be eliminated. You can set y up to be eliminated. You can make the coefficient in the first variable, in the first equation, make the first coefficient positive or negative. The second one just needs to be the opposite coefficient there. So hope that video helped you. See me in the next one.